In this tutorial, we are going to prove that root 2 is an irrational number by the method of contradictory proof. In contradictory proof, we have to assume something opposite to the given fact and try to establish it by our further logical steps. But in some of the steps, something will happen very peculiar, and we shall try to see the reason why it is happening. Ultimately, we see that our assumption is wrong. So again, we are bound to conclude that the given fact is true. That is the principle of contradictory proof. Okay, so in this problem, we are getting the solution. Let us assume that root 2 is a rational number, and it can be written as root 2 equal to a by b, where a and b are co-prime, implies root 2b whole square equal to a square, implies 2b square equal to a square. Now a square has two factors, 2 and b square. Both are positive integers. Implies 2 divides a square. Implies 2 divides a also. By theorem, recall that the theorem, if there is a positive integer a and there is a prime number p, then if a square is divisible by p, then a is also divisible by p. That is a theorem. So here a is a positive integer and a square is divisible by a prime number which is 2. That's why we are adopting these steps and not b square. Okay, 2 divides a square implies 2 divides a also. By theorem you can write shortly. Implies a is equal to twice m. If 2 divides a, then a can be written as 2m for some integer m. Again, from above, b square 2b square equal to a square. Instead of a, we are putting this value. Okay, so twice m whole square implies b square equal to 2m square. These two cancel, and from these 2 to 1 2 is cancelled, remaining 2m square. Okay, same way actually we see that here b is the dividend and it has two factors 2 and m square, and we need to adopt the prime number 2 so that we can adopt the theorem, this one. So implies 2 divides b square implies 2 divides b also, right, by theorem. Implies b is equal to twice n for some integer n. Now from 1 and 2, see 1 and 2, we see that both a and b have 2 as a common factor, which contradicts the fact that a and b are co-prime. Why? Because a and b are co-prime means HCF of a and b equal to 1, but we are getting is HCF of a and b as 2. Now you can say that it was therefore due to our wrong assumption only, hence root 2 is an irrational number. It is proved already. I hope you have got the point.